Welcome back. This is your teacher, David Garcia, and today we will be working with system of quadratic equations. Now, before we begin and we start solving problems, I want you to take a look at the ideas behind what we're doing. Now, so far, when we were solving a system of equations, we were solving linear equation systems. So the answer or the solution to that system of equation was a single point. Single point that would give us the coordinates of the intersection, or in other words, the x value and the y value that will be identical for both lines. Now, we will continue finding this point. That is the idea. But quadratic equations may present different shapes. So a single point sometimes may not be the only possible scenario. So let's see what the different scenarios may be. So scenario number one. In this case, we have these shapes. These shapes are known as hyperbolas. Now, if I zoom out, I will see that these shapes are very much parallel as we move further and further away. But right here in the middle, if I zoom in, I will see that they are touching. They are sharing a point. This is an intersection point, so to speak. There we go. And this is an answer. This is actually the only answer for this system of quadratic equations. Now, quadratic equations, as we said, may have all sorts of different shapes. In this case, here you see we have two circles. Now, the way these two circles are intersecting each other generates two possible solutions because they intersect at two different points. So the answer for this system of equations would consist on two different points. Let's see a different scenario. In this case, we have a parabola, that is the name of this red line, and this is an ellipse. Now, if we zoom in, we'll be able to see that these two shapes intersect right in here, right over here, and here's the other point. They intersect in three different points. So this system of equations will have as an answer three different points. Let's see another scenario. Now let's zoom out. All right. Here we have a circle and again a hyperbola. Now, in the way these two shapes are intersecting, we'll find that there is one point of intersection here, one over here, another one here, and yet another one down here. So this system of quadratic equations will have four different points as an answer. And now let's see the final scenario. This scenario that we're going to see right now is very much the equivalent of two parallel lines in the sense that they will never touch each other. What we have in here are two different hyperbolas. And if I continue zooming out, it becomes very obvious that they will never intersect. So for this system of equations, there is simply no solution. Now, how are we going to solve this on paper, algebraically? Let's see an example. Now, in the example that I'm going to show you right now, we have a scenario in which we will have 4 points. And I have chosen this because it's what can be considered, the longest type of problem for this topic. So the first equation is negative x squared plus y squared plus 14x minus 10y minus 48, and this equals 0. Second equation is negative x squared plus 6y squared plus 14x minus 60y minus 48, and this equals 0. Now, the easy part about this is, as these quadratic equations will be sharing points in most of the cases, you will have a lot of, let's say, equalities, all right, from one to the other equation. So we have to take advantage of that. So let's begin by, if we take this equation right here and we multiply it times -1, we will be able to change the symbols for these numbers right here, these terms. And we will end up with an equation only with the y variables, and it'll be very easy to solve. So let's begin from there. We will have positive x squared minus y squared minus 14x plus 10y plus 48, and this equals 0. If you see, what I'm doing is I'm applying the idea of method of elimination to solve this. So now my x squared will get canceled, 14x will get canceled, and the 48 will get canceled. So now I have 6y squared minus y squared. This will be 5y squared. And then negative 60y plus 10y. This will be negative 50y, and this equals 0. Now I have to factor this equation. So I'm going to use 2 parentheses to factor this. So if you see, as like terms or common factors, I have the 5 and also the y. So I'm going to factor 5y, and the other term will be y minus 10. Now that I have my 2 terms, I can write them as 5y equals 0 and y minus 10 equal 0. So the only possible solution is that in here y equals 0 and in here y equals 10. So if you see, I have already gotten, right, 2 of the coordinates for the variable y. Now, in the same way as before, it's just a matter of substituting either of these values in either of these equations to get the other values of x. Now, if by any chance you get a 0 in these processes as a result, I recommend you use this because it'll be way easier. It doesn't matter if you use a 10, you will get exactly to the same result. But using a 0 makes always things easier. So let's copy this blue equation. And let's substitute this y as 0. And this will make automatically this term to disappear and this term as well. So I end up with x squared minus 14x plus 48, and this equals 0. So now I have a trinome. So I need to factor this. So I'm going to open up both of my parentheses, and this will equal 0. Now, if you remember, the first term has to come from the multiplication of both of these terms in parentheses. So I will have x and x. Now, the second term in my parentheses has to comply with the following idea. When I multiply these two numbers, I have to get my 48. So they have to be factors of 48. And when I add them or subtract them, either way, they have to give me, or they have to be equal to this negative 14. So very quickly, we can identify that 6 times 8 are 2 factors for 48. And if I add them, they will equal 14. So let's write 6 in here and the 8 in here. Now, if you see, if I am multiplying these two numbers, and they are giving 48 positive, but when I add them, they give me 14 negative, automatically I know that both of them have to be negative. So now I have my trinome factored. So now I can write them as individual factors or terms, and I equal them to 0. So I find that x will be equal to 6 and x will be equal to 8. So in this system of equations, if you see, I have 4 points and I already have the coordinates. I have the values for the x coordinates and the values for the y coordinates. So it's just a matter of combining them. So my first point will be 6, 0, and then 6, 10. Now for my second value and my second set of points, I will have 8, 0, and 8, 10. And this is my final answer. So that's it. Thank you very much, and I will see you on our next video.